Hello everyone, it's me Anila and you're watching Math with Anila. As per reminder theorem, we know that when f of x is divided by x minus a, then f of a is the remainder. So what the factor theorem says is the remainder is equal to 0, then x minus a is a factor of f of x. That is what the factor theorem says. So as per the remainder theorem, we are getting f of a as the remainder, and if this remainder is equal to 0, then we can say that x minus a is a factor of f of x. By using this factor theorem, we can factorize the polynomial completely. Let's consider some of the examples. Given f of x is a polynomial in x and it is equal to 3x square minus 5x minus 2. And we need to show that x minus 2 is a factor of this polynomial. So x minus 2 is a factor. We need to find what is a remainder here. And when the remainder is equal to 0, we can say that this is a factor. So as per the remainder theorem, x minus 2, if you are dividing a polynomial by x minus a, f of a is the remainder. So consider x minus 2 is equal to 0. This implies x is equal to 2. We have to find the remainder f of 2 here. F of 2 is equal to, substitute x is equal to 2 in all these places. We will get 3 into 2 square minus 5 into 2 minus 2. So that is equal to 3 into 4 minus 10 minus 2. It's 12 minus 12, that is equal to 0. So we got the remainder f of 2 as 0. Therefore, what we can say? We can say that x minus 2 is a factor of the given polynomial 3x square minus 5x minus 2. Now, let's factorize this polynomial completely. So what you need to do is, you have to divide this polynomial by x minus 2. Right, 3x square minus 5x minus 2 divided by x minus 2. The division process, this will be 3x. It is 3x square minus 6x. As usual subtraction, you will get it as x minus 2. Again plus 1. You have to multiply x minus 2 here. So the remainder is 0. So we got the quotient as 3x plus 1. That means the factors of 3x square minus 5x minus 2 are x minus 2 and 3x plus 1. Therefore, 3x square minus 5x minus 2 is equal to x minus 2 into 3x plus 1. Since this was a second degree expression, we got two factors here. Now let's consider a third degree expression. Given f of x is equal to x cube minus 7x square plus 14x minus 8, and show that x minus 1 is a factor. So how can we show that x minus 1 is a factor? You need to find the remainder here. So as per the remainder theorem, the remainder is f of 1, since x minus 1 is equal to 0 and x is equal to 1. Now you need to substitute x is equal to 1 in this expression. You will get this as 1 cube minus 7 into 1 square plus 14 into 1 minus 8. So that's equal to 1 minus 7 plus 14 minus 8. So it's equal to 15 minus 15, that is 0. So you got the remainder as f of 1, that as 0. Therefore, what we can say? We can say that x minus 1 is a factor of f of x. That is this x cube minus 7x square plus 14x minus 8. Now, let's factorize this expression completely. You need to divide the given expression by x minus 1. So here, you'll get this as x square. X square into x is x cube minus x square. Subtract it. You will get this as minus 6x square plus 14x minus 8. Now, minus 6x square by x is minus 6x here. 6x into this term minus 6x square plus 6x. This will be plus, this is minus, this get cancels, and here 14 minus 6 is 8x minus 8. Again this is plus 8, this will be 8x minus 8, that is the remainder is 0. So you get the quotient as x square minus 6x plus 8. So when you are dividing f of x by x minus 1, you got the expression as the quotient as x square minus 6x plus 8. Since this is a second degree equation, we have to divide this again. We have to factorize this again. So how can we factorize? You need to consider the sum here, that is minus 6. And you need to split this minus 6 into two terms such that the product of those two terms are equal to the product 8. So what are the numbers? That can be minus 4 and minus 2. When you're adding minus 4 and minus 2, you're getting minus 6. When you're multiplying these two, minus 4 into minus 2, you'll get the product as 8. So we can write this expression as x square minus 4x minus 2x plus 8. So take x common, x into x minus 4 minus 2 into x minus 4. Group the like terms, x minus 4 into x minus 2. So the factors of the expression x square minus 6x plus 8 is x minus 4 into x minus 2. Therefore, f of x is equal to, that is x cube minus 7x square plus 14x minus 8. That is equal to, when we have factorized, we got the first factor as x minus 1. So x minus 1 into x minus 4 into x minus 2. This is how we can factorize the polynomials by division method. Consider another expression, f of x is equal to 2x square plus ax minus 3, and 2x plus 1 is a factor. So in this question, the value of a is unknown. Using the factor theorem, let's find it out. So given f of x is equal to 2x square plus ax minus 3. Now as per the remainder theorem, you can just write this as 2x plus 1 is equal to 0. This implies 2x is equal to minus 1 and x is equal to minus 1 by 2. Now find the remainder, that is f of minus 1 by 2. Substitute the values here in this expression. You will get this as 2 into minus 1 by 2 the whole square plus a into minus 1 by 2 minus 3, and that is equal to 2 into 1 by 4. The square of minus 1 by 2 will become plus 1 by 4, and minus a by 2 minus 3. Now it is given that is equal to 0 because 2x plus 1 is a factor. Therefore, f of minus 1 by 2 is equal to 0. Now, take the LCM of all these terms here. Before taking LCM, you have to cancel and write this as 2 here. This implies 1 by 2 minus a by 2 minus 6 by 2 is equal to 0. So, this will be 1 minus a minus 6 whole divided by 2 is equal to 0. Multiply 2 with 0, this becomes 1 minus a minus 6 is equal to 0. This implies minus a minus 5 is equal to 0. Bring a to the other side, you will get minus 5 is equal to a, or the value of a is equal to minus 5. So by using the factor theorem, we can find the unknown terms